Okay, hello guys and welcome to my channel. Now here we want to learn how to integrate a polynomial function. Well, let me show you how a polynomial function looks like. If you have a polynomial function of an independent variable x, it is defined to be equal to a0 plus a1 x to the first power plus a2 x to the second power and so on. Plus an minus 1 x to the n minus 1 power plus an x to the n power. Alright, now notice 3 dots means you have a lot still going. Okay, so here we have a polynomial function of how many terms? N plus 1 terms. Great. Here you know that the power of x right here is 0. That's why we're just having a0, a1. What are these? All this a1 and whatever. Well, a0, a1, a2. So we just say ai. Okay, where I is equals to 0, 1, 2, and so on. All right, is or are constant. They are constants, or you can call them coefficients. Constant coefficients. All right, they are constant coefficients, and they exist, okay, to the, let's say, j's power, where j2 starts from 0, 1, 2, and so on. I can put here x to the power 0. It's just like that, all right? They are the independent variables. No point writing them. Independent variable, the polynomial function in terms of x. Very nice. And our best concern is to integrate the polynomial function. So just know that this is a constant and these are variables. Okay, let's go ahead and integrate that. So if you want to integrate a polynomial function, of x, you're going to integrate that with respect to x. And what are we going to have? Well, we are going to say, I'm going to tell you this, that the integral of a sum is the same thing as the sum of the integrals. What do I mean? If you have a two function of x, f of x and g of x, so we say the integral of f of x plus g of x dx, okay, it is the same thing as saying the integral of f of x dx plus the integral of g of x dx. Well, should we call that the distributivity property? Of course. So the integral of the first component plus the integral of the second right there is this. So the integral of the sum is the sum of their integrals. Same thing with difference. Okay? Plus and minus, it works for plus and minus and not multiplication, neither division. As for multiplication, well, some functions for multiplication we can use integration by parts. Alright? Great. But for this case, we just go ahead and use the power function method that we just created in our last video. Very nice. So we're going to apply this right here, and you see that these are some of different functions of x. So we can call it g of x, f of x, h of x, m of x, any of x, any function of x. So we just have it that the integral of everything is the sum of the integrals. So I'll say the integral of this, the integral of this, and so on, right? So I'll just say the integral of a naught, where x to the power 0 is just 1, dx, plus the integral of a1x dx, plus the integral of a2x squared dx, plus and so on, plus the integral of an minus 1x to the power n minus 1. And you know how to do this one. You can take it home, right? Okay, great. So let's just go ahead and integrate all of them. And now, let me just complete this stuff right here. I believe you know the power of x right here is just 0, okay? Dx. So we're going to integrate this like we did last time. Again, let me tell you. Observing that these are constants, a0, a1, a2 till an minus 1, and even an. You are going to do that one, right? Observing that these are constants. Note, if you are integrating a constant with respect to any variable where the constant is not the variable, it is very, very okay to take the constant to the front of the integral sign. That is, it is a good practice to have the constant right here and just have your dx like that. All right? Very good. Okay, just very constant. It is the same thing. So because of that, I'll tell you, well, you can take your constant to the front of the integration sign. Let me just do that and show you guys. That will become a naught integral of x naught dx. In fact, x naught is just 1. Okay, plus a1 integral of x dx plus a2 integral of x squared dx plus and so on, so on, so on, plus an minus 1 integral of x n minus 1 dx. Like that, very nice. And you know how to integrate a power function, right? Great. Here we are having a problem. The integral of dx, 1 is here, or nothing is there. The integral of dx, well, if you differentiate a function x with respect to x, you're going to have 1. So if you integrate that 1, you're going to have the x antiderivatives. So the integral of the differential of x is just x. Just take it like that, right? Where we here is 1. Or better still, we were having x naught here, right? Great, let's just apply our power function rule. We have x to the 0 divided by 0, isn't it? It is, right? Well, you add 1 to that, and you add 1 right here. What are you going to get? Well, you're going to get x to the power 1 divided by 1, which is just x. Isn't it? It is, right? Again, we will have 0, 1 multiplied by x. This is power 1, right? Yes. We have x to the power 1 divided by the 1. You add 1 to that, and you add 1 to that. Okay? Next time, let's just do it straight. We have plus a2 x to the power 3 divided by 3. Isn't it? Very good. Plus, and so on, so on, so on, plus an minus 1. This is a product, so I can just use like this. Very good. Well, we will have x to the power what? This is just power n, isn't it? N minus 1, we add 1 to that, divided by n minus 1, we add 1 to that. Where negative 1 or positive 1 gets to 0, so we just have it to be an minus 1 times x to power n, right? Plus, plus, here is just a2 x to the third degree divided by 3, plus x to the second power divided by 2, a times that, this is just a1, plus, this is just x, like I told you, we write it properly. And don't forget to add your plus c. Like this, we have integrated our polynomial function. And you know what? The integral of the constant in a naught is going to give us, oh, this is a naught, alright? Okay, I missed out. This is just the a naught. So we're going to have a naught with x. So you see how the powers are now getting over? The power is now starting from what? Instead of 0, it starts from 1. This one gets to 2, this one gets to 3, this one gets to n, and this one will get to what? N plus 1. When you integrate that, you're going to see, right? Very good. But you just brought in another constant, c. Oh. What is this telling us? X to the power 0 again. So, the integral of a polynomial function is a polynomial function. Alright? Okay, thanks guys for watching this video, and of course, you'll be grateful. Please subscribe to this channel.